The problem developers face when building ZK apps is the fact that smart contract state is actually only limited to 8 variables. Only a limited amount of data is allowed to be stored on chain so that it can remain succinct and not bloated. However, if you wanted to build an application like a leaderboard or even a voting system, you definitely would need more than 8 variables. And the solution to this is Merkle trees. If you'd like to learn more about Merkle trees, then check out this explainer video. The way that we use Merkle trees when you're creating smart contracts on the Mina blockchain is that you store only the root of the Merkle tree on the smart contract state. Using the root of a Merkle tree is a really great way to compactly represent a large amount of data. This is a great data structure for storing data efficiently within your smart contracts, and thanks to the Snarky.js library, it makes it very easy for you to create and interact with the Merkle tree. Don't forget to subscribe to this channel for more technical walkthroughs as well as coding tutorials. For this example, we will create a voting application where we will vote on the top 10 songs this week. We're going to use a platform called Song.xyz, Web3 platform, which allows you to easily buy Web3 music. We're going to check out the top 10 viral songs this week and vote on which one is the best. So let's jump into the code. Make sure you have the Mina ZK app CLI installed, and there are instructions here. And now we're going to start a project. If this is your first time, you could definitely check out my previous tutorials where I show you how to create a ZK app. Open your terminal, go to a folder where you store your code. Now the first command you're going to run to create a project is called ZK project. So ZK project, and I'm going to call it Sound XYZ voting. We are not going to create a front end for this project for now. And now we're just waiting for the files to be installed. Boom. So it's installed. So we're going to change directory using the cd command to go to that directory. Now we're inside. So if I do ls, we see we have a bunch of files already there and there's a source directory. So let's explore this further. So if we go into source, we see that we already have some files here, which is a smart contract called add and a test file. I'm going to continue working from this smart contract because it's a great base and there's already a test file created. So I'm going to rename this. I'm going to call it Sound XYZ voting. Hopefully that name has been changed everywhere. Perfect. Now I'm going to rename the smart contract as well. Sound XYZ thing. Yes. And then rename this Sound XYZ voting.test. Perfecto. Just name this Sound XYZ voting. Okay, awesome. So let's rename this to num voters. So that's one variable we're going to have as a state variable in the smart contract. Remember, you can have a maximum of 8. And I'm just going to duplicate that. I'm going to have another one called winning song, and then another one called winning votes. And then finally, we're going to store the root of the Merkle tree in the smart contract state, and this tree will have the votes. So I'm just going to call it tree root, and that will also be of type field. Awesome. Now I'm going to create a method to initialize the state on the smart contract, and I'm going to initialize it with the initial root of the ZK app. So I'm going to say this tree root.get initial root, and that will be the method that we will. Why is it saying? Oh no, that's set. Sorry. And this method will be called instead of init. Well, we will have to call it manually. Init is called automatically, but because we want to do something a bit more special, we're creating our own method. I'm just going to ignore this update method for now. Now I'm going to create a struct for representing this song. So I'm going to say export class song extends struct, and here it tells you like how you create the struct object. Okay, so I'll make it look something like this actually. And then in the struct, I'm going to create a variable called song name, make that a field, song votes, make that a field, and song artist, that's also a field. And then I'm going to create a method called vote, and the way that this method works is by doing song votes this dot song votes is equal to this dot song dot add. I'm not doing this properly. Let's see. Oh, we have to import struct from Snarky.js. And then let me hover again to see the example. Oh yeah, of course. I have to make it look like a function. Beautiful. And I will say, yeah, there's nothing really to take in as a variable. Awesome. So now I have that. And now we are going to work on the method, which is vote for song. So method vote for song, and it takes in the song as a variable. And what we want to first do is we would like to get the tree root currently, and we would like to see if the song is in that root. So the first thing we do is get the tree root, And then we would say constant tree root is equal to this dot tree root, because we're getting it from the smart contract, which is what we're writing in. That's why we're using this. This dot tree root dot get and the state equals. So this basically gets the current on-chain state and prove that it really has to be equal to the on-chain state. So we're just making sure that the state that we pulled into our smart contract when we're executing this, which actually doesn't happen on-chain, we're just making sure it's equal to what is actually stored on-chain. The next thing we want to do is we want to check to see whether the song is in this Merkle tree. The way that we check to see whether the song is within the tree is via something called a witness. The witness is a path from one specific leaf node all the way to the root of the tree, and Merkle witnesses proves that this actual item is included in the tree, and that is what we're going to do for our application. Another thing to note is when you are creating a Merkle tree, you do have to specify the height of the Merkle tree, and the height basically says how many leaves we can have. So if you have a height of 4, then you can have 2 to the power of 4 leaves, which is 2 multiplied by 2 multiplied by 2 multiplied by 2, which is 16. Because we're only going to have 10 songs in this tree, I'm just going to make the height as 4. And when you do have to do things like specifying the witness of a Merkle tree, you do have to specify the height of this Merkle tree. So the way that you do that is like this. You create a class for the Merkle witness. I'm going to do the same thing for me in this app, and I'm going to export class, and in our case the Merkle witness will have a height of 4, and export constant tree height equal to 4, and then tree height, and then I just need to import this. Awesome. So in our case we will need to accept a variable called path, which is of type Merkle witness 4. And this path basically will be used to, or path or witness, you can call it one of those things, because basically the witness is the path from that leaf node to the root of the tree. So we're going to say path.calculate root, and you have to put in the field, which is what is expected to be found on a leaf. In this case, it will be the song, but it can't be the song because the tree actually only stores field variables. The field element is the basic unit of data in zero-knowledge proof programming, so we have to store it as a field. So we can't just pass the song because right now the song is a struct. So what we will do is we will hash it down into fields. And the way that we do this is first we use the song struct and we say 2 fields so that we can convert this into fields. But then we also store a hash of that in the tree. We'll see that later on, but I'll just do Poseidon.hash. Poseidon is a hash function for zero-knowledge proof systems. I'm not going to go into that detail, but just wanted to pull up this paper. All right, so we are going to say song constant song root is equal to that. Now we're going to do an assert, which is basically checking a constraint for our smart contract. So we are going to say assert that song root dot assert equals the tree root. If this assertion fails, there will be nothing to be sent to the blockchain because the zero-knowledge proofs already proves that this is invalid because the song doesn't exist. If it does exist, then we can continue. So if the song does exist, then we do want to cast a vote. So now we want to vote for this song. So we're going to say song.vote, which is a method that we defined up here, which increases the votes for that song. Now we'd like to update the tree, right? So by updating the tree, it means that the leaf now has this new song object, which has the incremented votes. But in the smart contract, we only have a storing the roots of that Merkle tree. So what we want to do now is calculate what the roots would be at that particular path if the object that is being hashed is now this new song object, which has the votes incremented. So to do that, we're going to calculate the new song root. Wait, I'm going to just put some comments. So include updated. So we're going to say new song root is equal to path.calculate root Poseidon dot, I hope I'm pronouncing that correctly, dot hash sound.to fields. And then I'm going to put the song object, which now has the votes incremented. And I'm going to update the tree root in the smart contract, which is this dot tree root dot set new song root. The tree remains the same, it's just that the root is a little bit different because remember, you're hashing everything. And therefore, since this song changed, that hash will then change all the way at the top as well. We want to increment the number of voters, so increment num voters. So this dot, so we say this dot num voters dot set, which is this dot num voters dot get, and the set equals dot add 1. And what else do we want to do? We want to check to see whether that song is the winning song. So we need to see if the number of songs, we need to see if the number of votes that this song has is greater than the number of votes currently of the winning song. So what we'll do is get current winner and update winner. So we will say this get this dot winning song dot get and assert equals. Do the same for the boats. Get and assert equals. Now we're going to say new winning song. Depends on whether or not the current song is greater. So new winning song is equal to provable if, and we're going to say if winning votes is less than the song votes, then the new winning song is the current song, song name, or if not, then it'll be the current winning song. And then similarly, new winning votes is equal to provable if. All right, so now we're just going to set it, like update the state. So then we're going to say this dot winning song is equal to new winning song. Oh, not equal to, dot set. And then we're going to do this dot winning dot set new winning votes and la-di-da. All right, so that seems like it makes sense. So we are updating the root of the tree, the number of voters, and the winning song, as well as the winning number of votes. All right, so that's our smart contract done. By the way, the fact that we are creating a ZK app smart contract, it would make it so that if someone is voting, you have no idea who they're voting for because the input is actually private in a smart contract. So this input will be private, but I digress. So now the way that we're going to test this is by using test-driven development right now, just so we can test on our local blockchain. So I'll just update it. Import the tree height as well as the song struct and the Miracle Witness 4 class from the smart contract. And then I will add as part of a variable for this test, I will add the tree, which is of type Miracle tree. And when I'm initializing before each test, I'll say tree is equal to create tree, which is a method that I will create, and change this to a come. And then where's the method create tree? I think I'll put it on top. So what I'll do in this create tree method is I will create a bunch of songs and store it within the smart contract. So I will first do another function called create song, and I'll pass in the song name and then song artist and type string, and then I would say constant song is equal to new song, and the song name is equal to Poseidon hash song dot hash song name to I'll create the song. So hash, I will convert it to a circuit string dot from string song name, and then song artist is equal to a similar thing. And then the next one is the num votes. What is it called? Song votes is equal to field 0. Then I'm just going to import this and stuff here. Import circuit string from string is not assignable. Oh, right, I have to do 2 fields because that's what that method takes in. Awesome. Source. All right, so song is equal to that, and then I'm going to return song. And then to create a tree, I am going to say constant tree is equal to new Miracle tree of height tree height, which is 4. And then I'll now set the leaves of the tree. And so the tree.set leaf starts at 0n. It has to be a big int. And then the leaf will now be a field. So it would essentially be a Poseidon dot hash of a song dot to fields the song, right? With this song, and then I'll say so the song is not created yet. So then I will say constant song 1, call that song 1, song 0 to make it line up. Song 0 is equal to new is equal to create song, and then I'll just get the song name from song.xyz. So song.xyz, the first one is what's it like to lose. So first you put in the song name, right? So then I'm gonna set the leaf for each one. I mean, ideally this will be in a for loop, but I'm just trying to be really quick here. All right, and then we're going to return tree. All right, awesome. So when we deploy the ZK app, we need to also run the init state, with the tree.get root. So that could be set as the root of the tree in the smart contract. So I'm going to walk through the code that I wrote for all of this. This will also be on my GitHub. Okay, so what we're going to do now is walk through the test that I created. So the first test that I created is after I did the local deploy, because in the local deploy method, I initialize a tree state. I would like to just make sure that the root of the tree is on the smart contract is the root of the tree that I have. So I just check to see if that was equal. Let me just run the test right now, just so that can run. And then the second test I did was that it correctly votes for a song. So I created a song that I know for sure is on the tree and I know the position is at index 1n. I got the path for the song, and remember a path or the witness is essentially the path from the leaf node all the way to the root. And then by doing that, I was able to vote for the song. And once I vote for the song, I verified things like the number of voters equal to 1. The winning song is the same song that's in that object, as well as the winning votes being 1. And then I had to update the tree root because remember the song object changed because now it has 1 more vote. And because the song object changed, that means that when you hash that song object, it will now be a new hash. And if there's a new hash for the song object, then all the hashes will essentially change in the tree and the root of the tree will also change. So you have to now recreate the tree, if that makes sense. So I set the leaf of the local tree with that new song since the object has been updated. And in the smart contracts as well, I would have set the root as well. After you vote, you will then calculate the new root based on the new hash of this particular song. And then I would have set the root as this new root. And I just checked to see if the root of my local tree is the same as within the smart contract. The third test I did is that I'm just making sure that you can't vote for a song that isn't in the tree. So if you have a song called Satoshi Nakamoto, even if I do put the Optimism Collective as the artist, and I try to put it at path 1, which we know there's another song there, but let's just say we put it at that path 1, or we assume it's at path 1, then we then send that path and that song to the tree. And if that transaction was successful, then voted will be set to true. Otherwise, it'll remain as false. And we just want to expect that to be equal to be false because the transaction would not be successful. And then in this transaction was where I voted 3 times, twice for one song and then once for another song. And I wanted to prove that by voting 3 times, I'll be able to pick the correct winner. So I had 3 transactions. The first one voted for song 0. And after I voted for this, well, before I vote for the song, I get the path. After I vote for the song, I make sure to increment the votes on that song. And I also update the leaf in the tree. Then I do the same thing for path 1. I get the path for path 1 at position 1 in the tree. I do the votes and I also set the leaf locally because that happens as well in the smart contract. I get the path again for the song. Even though I had the path earlier for path 0, I need to get it again because I have updated the leaf. And since I updated the leaf, the root of the tree will also change. So I need to also get the updated path because remember the path is essentially the path it takes to get to the root. And if the root has changed, then the path will change as well. And since I voted for song 0 twice, I expected the winning song to be song 0, the number of votes to be 2. I expect 3 votes because I voted 3 times. And I expect the root also to be the same root locally as in the smart contract. And I see that the tests have passed. After I did that, I decided to deploy the smart contract. And let's see if you can see those here. Yeah, so I deploy the smart contract. And if I go to the smart contract here, the first transaction I sent to the smart contract was actually initializing the state of the ZK app. So if we look at this transaction within the Blockchain Explorer and we look at the raw data, we can see that at first the state was set at null. And then when I added the tree root in the smart contract in the initialize state method, it was then set as the hash of the root of the tree. And just to show you that method within my code, in the smart contract, there's one that's called init state. And then there's this hash here, which is where I was able to vote for a song. And when I vote for a song, then the other fields were updated to 1, which is the number of votes. This is the winning song. This is the winning number of votes for that song. And then also the true root changed because remember, since I updated the votes on that song, the true root will change. And that's it. So if you would like a video showing you how to read the Blockchain Explorer, let me know. This is an example of the same smart contract, but before I did the vote. And then I have an example here showing the app state after I did the vote. So the app state is in the smart contract. If you go on the smart contract page, you can see it here. These kind of videos are very helpful for you if you are building Zika apps on the Mina blockchain or want to learn about it. There's also a program that they have running now called Zika Ignite, where you can bring your ideas to life and they will give you funding and you will build those ideas and then they'll pay you once you complete your milestones. They have 500,000 USD and 500,000 Mina available in funding, so definitely check it out. Hope you enjoyed this video. Please subscribe and give it a like so it can spread all around YouTube. See you in the next one. Bye.